Hello, everyone. Jumping into the Zoom. I'm here with Ben Sigelman, aka BHS. Ben is the CEO of Lightstep, one of the co-founders of OpenTelemetry, and a good friend of mine. So I'm really excited about sitting down to do this interview. People are still piling in, but because we want to respect everyone's time and ensure we have as much time as possible for Q&A, we're just gonna get started. Format of this will be an interview for 20, 25 minutes, and then at the end of that, we'll switch to Q&A. So let's hit it. So Ben, how you doing?
I'm great. Good to be here, Ted. I'm excited.
Awesome. Yeah, so I feel like, you have a long history in the world of observability and tracing all the way back to Dapper at Google. People can find that history on the internet with a quick Google search. But what I wanted to ask you, because you've been around so long, is a discussion we've been having a lot about is how tracing just improves observability in general, but hasn't actually been, is like kind of the least known of all of the observability tools, even though from our perspective, it's pretty foundational. And so I kind of wanted to start this discussion by sort of looking at the history and just kind of asking, why is it that people see logging and tracing in particular as two different tools? Why don't they just use tracing?
Yeah, it's definitely a good question. I mean, it might be helpful to level set a little bit on just some definitions. There's really, at the end of the day, there's only two types of telemetry that will come out of any piece of software. There are events in some form, whether that's logs or kind of a type of event. It's like something happens, or tracing divided into little segments called spans. Typically, those are also types of events. So they're kind of categorically one type of data. And then there are statistics, where you're actually, doing some statistical thing inside the process itself. The most simple version just being literally counting how many times something happens. But there are other statistics like CPU averages and things like that you export periodically, and that's usually called a metric anyway. So there are those two broad categories, and logging and tracing are definitely very similar structurally. Logging predates tracing, and I think that's part of the reason why it was more common. It's just that it was already there. And then the other reason, which is probably more important, is that the whole point of tracing is to follow a specific transaction, like a user request or something, some kind of business operation that's happening in the application, and to follow it from service to service. And that requires the propagation of some kind of state to identify that transaction. And that propagation is not easy. At Google, we were able to take advantage of some good design decisions that people made before I came along, to factor out the way they do RPC calls, to factor out the way that they pass control from one thread to another. That was all really clean at Google. And so it was relatively easy to layer on context propagation on top of that. In many environments, that wasn't the case. And I think that's why tracing was difficult. I actually have some slides that are really, really brief about just this stuff. I thought it might be helpful to show them, just to explain again that I think some of these core concepts. But if you have a transaction in the system, the things in the application that actually do something. For cloud native apps, they're almost always distributed, which is to say that the transaction involves work in multiple different VMs, basically. And you can describe transactions at many different granularities, anything from user requests down to individual HTTP calls, and theoretically down to local function calls. So I want to be clear that the granularity of a trace can be quite variable, actually, and depending on how much value there is in that trace, you can decide how much you want to spend on that telemetry, basically. And theoretically, you can even go down to CPU instructions, and there are very high overhead tracing systems that that exist that will do profiling at that level. They're just typically too expensive to bother with it. So the hypothesis in my mind is that tracing will eventually replace logging. To be clear, like this is a conceptual logging statement. You have a struct that you're logging. There are a number of fields in that struct. This is for the best case of structured logging. We can talk about that if you want, where you might keep track of, for a request, the size of it, the path you hit, the status, the latency, column in some table that's being described. And the problem here, and this is really, really important, is that this logging struct as it stands does not identify the transaction that it's a part of. And that is the Achilles heel of logging and the reason why it's not, I think, appropriate for distributed systems. What you end up seeing, and this is the anti-pattern, and I think a lot of people will see this in their code, is that somehow you have some struct that you're passing around in your code that's like a manually propagated context, and then you like join against it and take a bunch of fields and log them with your logging statement. If you have some struct like this that you're passing around manually in your application, that's basically like manual tracing, and it's a pretty painful thing to do. And doing it this way it has all sorts of other drawbacks. But this is the anti-pattern that usually suggests that logging has ceased to be effective in an application, is the manual propagation of some kind of user context all the way through the stack. There are better ways to do that, which Ted can definitely talk about as well in the tracing world, but this is manual tracing. What you want to do is automatic tracing, where you basically do this join across your system. And if this was the table from your logs, where each one of these fields ends up being a column in this table and each transaction ends up being a row, what you want to be able to do is join this table against every other logging statement or tracing statement that transaction hits, and say, for each one of these services, a transaction will propagate through them. There might be a logging statement at each. And the beauty of tracing is that you can automate the process of joining all of these structured logging statements together into one table. So this is a lot of, conceptually, a lot to understand, but what I want people to understand, if there's one thing you take away from this, is that tracing is a join. Like that is what's happening. If you can think about logging as a table, which I think is the right way to think about it when you're doing analysis, tracing implements a join on that table and automates that process. And this is what tracing brings. It's not just being able to look at waterfall diagrams, but it's actually having a table for the distributed system. And then that enables a whole field of analysis on top of this. So that's a bit of a like hyperspeed overview of conceptually what tracing actually is. It's not just waterfall diagrams, it's a join. And where logging, I think, has issues where you can't understand how a transaction, you can't understand the relationships between the different parts of a transaction as it crosses service boundaries without manually propagating stuff, which ends up being error prone. So Ted, that's a lot of material, more than you asked for, but I wanted to cover that, and then I'll stop talking.
No, that's absolutely great. That's definitely a whirlwind tour. But to break it down further, when it comes to like logs versus tracings, you say they're both just event data. At the end of the day, you want to know what were all of the events that participated in a transaction and what is their causal relationship. And with tracing, honestly, you don't need that many extra fields, but there's a set of fields which are basically, what is my parent? What is my ID? What is my parent's ID? So that you now have a graph. And then what is the ID of the overall transaction? We call that trace ID, span ID, and parent ID. And if you have at minimum those three things, you now have your data turned into a graph or turned into a join table effectively.
Yeah, exactly. And as for why we didn't start with tracing, I did allude to it, but just to be clear, like it was difficult to implement. I think the problem is to make this join possible, there needs to be some kind of identifier that's propagated, as Ted was saying, that takes the form of some kind of trace ID, some kind of span ID for each one of these segments, each one of these tables, basically. And that was hard. And the whole purpose of the Open Tracing project, now the OpenTelemetry project, is to abstract that complexity into its own open source project that you don't need to understand the details of. And that's the purpose of those projects, is to bring context propagation, really, and then many other things that go along with it, to any piece of cloud native software without requiring an application developer to care, frankly, about the details of that propagation, which is exactly the situation we had at Google. If you look at the Dapper paper that we wrote about that system, in the abstract even, it talks about the fact that this was sort of only possible because of some good design decisions at Google. And to a certain extent, you can think of things like OpenTelemetry's tracing signal as an attempt to retrofit that design decision onto like all of open source software. And I think we're being somewhat successful there. I mean, that's why the project is has gotten so much velocity. But the idea is to make this as easy as logging. And I would suggest that for organizations that are able to adopt tracing, it really is like substantially more effective than logging in terms of value. And also like we've seen people reduce logging volumes by 95% by adopting tracing. So in as much as logging is a cost center, it can be pretty helpful from just a bottom line standpoint as well.
Yeah, I think those are all great reasons to adopt it. And just, I think to reiterate, I think the basic idea here is like, tracing and logging are both the same thing. It's about events, but with tracing, you have these correlations, IDs, and indices that you need. And if you could add all of these things by hand yourself, you could add these correlation IDs by hand yourself. But if you're doing that to your logging system, you're basically creating a tracing system, and it's a huge amount of work to get right. So it's not that people are doing the wrong thing by trying to start adding these correlation IDs to their system. It's just, it's so much work that having an industry standard, having everyone get together and come up with something like OpenTelemetry, where we can all agree on how this context propagation works, and then try to just get it baked in and available everywhere. That's just basically a time saving in terms of like a huge number of engineering hours you'd be putting in at your organization otherwise.
It's a yes and on that for me. I agree, but the problem is that it's worse than that. Like if we go back to this sort of anti-pattern slide where you're manually propagating things, it's conceivable to do this within the application code that someone actually can change and recompile. But in any software system, I mean, I'm making up the number here, but surely like less than 5% of the code is actually written by, that's being run, is written by the organization itself. Most of it is brought in through dependencies, whether that's, the kernel or, whatever, service mesh or something, right? But those infrastructure pieces often that are user space infrastructure, so it's not even like kernel level infrastructure. That stuff does participate in the transaction and can become overloaded and can create latency issues and so on and so forth. And I think it's fully unreasonable to expect someone to go and instrument that stuff. So another advantage of a project like OpenTelemetry is that, Envoy or whatever, service mesh, like that does actually adopt OpenTelemetry as well. And so you can see inside these dependencies you have. I mean, the illustration that I made here in my like horrible handwriting, this just talks about the user level stuff that this particular organization wrote themselves, but there's a lot of infrastructure that sits between that can also be instrumented using something like OpenTelemetry. I think Kafka is adopting OpenTelemetry as well. Like those sorts of things are out of scope for someone to change themselves. That dependency is too large to go and modify. So it's also helpful to get a multi-layer view into how transactions are actually behaving. And that's another advantage of this approach, I think.
Awesome. So tracing also has traditionally had some limitations associated with it that even for people who adopted tracing would have said it's not a good tool for logging. For example, sampling, the way sampling worked in tracing, where you basically roll a 1024 sided die. If it comes up a 1, then you sample that. Otherwise, you drop the data on the floor, so you're not, recording errors and other important events. Would you say like that's fundamental to tracing, those kinds of limitations?
Yeah, it's a really, really good question. And sort of, I don't have I'm sure people aren't sad to hear this, but I don't actually have slides for this this piece, but I kind of wish I did in a way because it's such a visual concept. But there's this idea okay, let's talk about why did sampling happen in the first place? So there are two reasons. The one that I think people assume is that without sampling, tracing has an interference effect, which is to say that by adding tracing to your application, it's going to slow it down. And there's this, the Hippocratic oath of observability, first do no harm. So you don't want to bring in observability technology and have it affect the performance of your application. And to a certain extent, that's a legitimate concern. I think at very high throughput at Google, when we did experiments, we found that adding unsampled tracing had a measurable effect on throughput, and certain situations a measurable effect on latency, although there's an asterisk there, which I won't go into, but it was in the single-digit percentage points or something. But the real issue with tracing unsampled tracing is not overhead, but just cost, like just dollar cost, full stop. It's just too much data. And so I think a lot of the reason that people end up adopting sampling is that the ROI doesn't go down that much. Sorry, the return that you get by adding, some sort of modest sampling is relatively similar to when it's unsampled, and the investment, goes way down because there's a cost savings. The thing that is, and I think that there's still work to do here across the board, but the idea that a transaction trace has a fixed cost is a fiction. I think I alluded to it in that earlier slide, but I mean, I think the end game here, which to be very clear, we have not reached as an industry, the end game is that different traces have different, what you're not just sampling yes or no, but you're saying, I want X% of my traces to be like fully verbose. Like I was saying earlier, like we're going to record every function call. And if you only did that, 1 out of 10,000 times, that's perfectly acceptable from a performance standpoint. And it would be quite valuable actually, because the super high frequency transactions where you want that kind of granularity, you'd still have enough data to do statistics. And then, for a larger percentage of traces, you'd be doing like standard granularity where you record every HTTP call, that sort of stuff. And then for every transaction, you're going to literally propagate the context and make certain, statistical statements or whatever. At Google, there's a project called Census. The Open Census project kind of derives from that. That's I think has been written about, so I don't mind saying it, that it's a tracing thing, but it doesn't generate performance data. It's used to do accounting for the cost of like lower level storage services. And so you could have a shared storage service and say, with multi-tenant, and you could say, how much bandwidth does each tenant get to use? And it was quite valuable in that Google could bin pack these really large, expensive storage systems, absolutely up to 100% allocation, and you didn't have any waste. And it was all enforced using the same code path that Dapper used for like performance tracing. That tracing, that like census tracing, was unsampled. I mean, it was 100% sampling, but it wasn't generating the same sort of data that like Dapper's UI does with the waterfall graphs and stuff like that. So it was higher performance. So I think this idea of tracing having a fixed cost is sort of a misnomer. So probably what we should be doing is 100% sampling for something, just like basic context propagation or whatever. And then, some sampling for other data sets, and then very aggressive sampling for the super verbose traces. And then you'd have a little bit of each, and our analytical tools would be more powerful as a result. But we're just not there yet. But I don't know if that makes sense, Ted.
I think it does, but I think I want to clarify what the problem you're discussing around cost of collection. Isn't this like a problem that logging also has? Like in the world of logging, you're basically doing what you're saying, which is you're storing all the data all the time. And if you want highly verbose data, like turning the debug logs on, then you're storing all of those all the time. And that's hugely expensive.
Yeah, I think I'm really glad you brought that up. So the difference between the logging and tracing version is that in logging, if you do sampling, it's kind of a local decision only, right? So you say for this particular logging statement, I'm going to just flip a coin and keep some percentage of it. In tracing, the coin is flipped for the entire transaction, and the value there that is pretty enormous. In that you say, even if let's say you do, 1 for 10 sampling, just hypothetically, and you do that in logging and tracing. That means that for a transaction that touches many different services in the logging world, you're basically guaranteed that you've lost, 90% of the data about every transaction, because you're throwing out 9 out of 10 of the pieces of it, right, independently. Whereas with tracing, you might end up with theoretically the same amount of data at the end, but it was done on a per transaction basis. So the data that you do have is complete on a per transaction basis and allows you to understand where the bottlenecks are on a per transaction basis. And since the analytical viewpoint, you want to understand the whole transaction, making those sampling decisions per transaction, it makes sampling like a defensible thing to do. Whereas in the logging world, like the plain logging world, it kind of destroys the value of the data in a distributed system. So that's a really good point that you're bringing up. I would argue that sampling and tracing is just far less destructive to value than it is in logging, and that's why it's been a defensible thing from a technology standpoint.
And when you talk, this is a bit of a leading question, but there are advanced sampling algorithms that are getting baked into OpenTelemetry and Lightstep makes use of, which is basically it's possible to record all of the data, or at least all of the baseline data locally or at some level, and then do what's called tail-based sampling. So if you're seeing rare but important events like errors and exceptions, you're always recording those. And so just circling back to like tracing replacing logging, this was seen as a limitation of tracing, that you had this sampling stuff, but it seems to me that it's actually an advantage. This is a way you can basically do your logging at scale and volume while dramatically cutting your cost without really losing data that you wish you had, essentially.
Yeah, for sure. And yeah, I don't have a succinct response to that, so maybe I'll skip it. But yes, totally. I mean, it is a leading question, but I'm glad you asked it. Sampling is not a yes or no thing, as I was saying, and even once you've decided to sample, there are different ways of approaching that, and many different places sampling can occur. And I think systems that do this right it basically makes the ROI in the event data so much larger than it would have been in a kind of conventional logging system, or even in like Dapper in a conventional tracing system. There are a lot of limitations the way we did it with Dapper that I think have been addressed by these more modern techniques.
Yeah. What about looking at traces in aggregate and statistical stuff? We've been talking about traces as events and how that relates to logging, but you can also do a lot of statistical stuff on top of tracing. Like, how does that work?
Yeah, I mean, I think that's the future of it. I mean, I don't actually think that people should be looking at traces very often. I mean, it should be possible to for people who want to dig in, but the real value of tracing, it's in the statistics for sure. I would go back to that image I had earlier with the join of the different parts of the system into one large table. To make this concrete, tracing is the only signal that we have that explains the relationships between different parts of the system that are being maintained by different teams. And since 75+% of issues in production are due to an intentional change made by some team somewhere, which is to say, like, intentional deployments of code and configuration lead to almost all of the incidents that end up causing problems for people. Tracing is the only data source we have that can understand those things, but it's not something that you can necessarily see on a per transaction basis. You have to look at a bunch of them in the aggregate, and I would argue you actually have to look at groups of them at multiple time periods, so a baseline and some kind of deviation period, and to look at how the statistics have changed over time. That's by far the most confident way to understand what has happened in a distributed system. And it's not that you look at individual traces. I mean, I think, not to plug Lightstep too much, but like the change intelligence stuff we built recently and deployed for our customers allows them to see that, oh, it turns out that, your CPU load went up in the last hour and you don't know why, and you didn't make a deploy, so what happened? And just to say, well, let's look at all the transactions, the traces passing through your system before and during this CPU spike, and just understand how the workload, like, well, what is the change in the workload? And I think rather than looking at a trace, what you want to say is like, well, it turns out that when customer X is involved, there are 25 times as many of these calls, or when service foo pushed version 5 from version 4, that specifically is the difference between the transactions before and during the incident. Those sorts of insights can be derived from the traces and presented in a very straightforward way, where you don't need to look at these crazy waterfall diagrams. You just see this thing that says, oh, it turns out that's a 98% correlation of this new service version and the incident that you're dealing with. And that's the real value of tracing. It's not in looking at the raw data, it's in aggregating it and looking at the changes in the statistics. So I think that's really where the field is going in general, and tracing is a big part of that.
Yeah, when people think about statistics in terms of operations and observability, they tend to think about metrics dashboards, right? Like that's the statistical tool that everyone uses today. But you're talking about statistical tools that are more advanced than just a dashboard full of metrics, basically.
Yeah, and I mean, I'm not a hater about dashboards. I think they have their place. I mean, ideally, there's some SLOs in there and everything. The issue is that when there's a change in a dashboard, it's often seen in many other places. Like the change will be observed in many charts and many dashboards. But to be able to go from one of those deviations to understanding, what was the original catalyst for this, that's something that requires more smarts than just dashboards and charts. Like you need to be able to have a tool that will guide you through the telemetry and the event telemetry specifically, coming from traces. But yeah, the people confuse the idea of a time series chart with metrics. You can make a time series chart, and a very useful one, out of other types of data, including tracing data. I only call something a metric if it was aggregated before it got out of the process itself. If you're exporting a statistic, that's a metric. But just having a time series chart, it could and should be derived from tracing in many cases.
Yeah. So I want to make a statement here, and maybe we can kind of close on this subject, but I'm going to make a statement and let me know if you agree with this take on it all, which is tracing data, when you have it, is basically properly structured data. So you have everything in your system structured in such a way that a machine can analyze the shape of your system and understand what it's doing. And when you're doing that, there's a bunch of work today that the operator does kind of in their head when it comes to gluing things together. So if they want to find all the logs in a transaction, they're doing a bunch of work to collect that data, right? You have to kind of search and filter. If you want to find just the logs in one transaction on a big system, my experience is that's a fair amount of work just to reduce the logs down to an example transaction. With tracing, that happens automatically. Then likewise, when you have some kind of alert and you're in a firefighting situation and you're looking at your dashboards and things, a lot of what you're trying to do is find correlations between all the different signals that you're getting. And an operator does all of that work in their head. In the past, I've even taken a ruler or a piece of paper and like lined it up on my dashboard to see which metrics were going squiggly at the same time. And with large scale, like statistical analysis of traces, that work is automated. So a lot of this is about basically time savings, stuff that an operator had to do in their head and kind of took a fair amount of time. But now the system is doing that automatically for them. So it's not solving the problem. It's not showing them like, here's what's wrong with their system, but it's saving them a huge amount of time when it comes to actually collecting that data and being able to see, objective analysis, like what's correlating with what.
Yeah, I mean, we should probably move to Q&A. And by the way, I'm happy to go over by 15 minutes if people want to
Yeah,
stick around. And we're recording this, so even if you have to go, we'll try to answer your question
absolutely.
and distribute the recording. But yes, absolutely. And I think the other thing I would add there is that tracing, it's the fuel, not the car. You know, it's like the fact that something has traces in it. I mean, both my lawnmower and my car use gasoline. Well, unfortunately, my car uses gasoline. I should get a new car, but that doesn't mean that they're the same vehicle. And so tracing is the gasoline. I would argue that it's not possible to understand distributed systems without distributed traces, but the fact that you have distributed traces doesn't mean you're going to solve your problems. And I've definitely seen a lot of people deploy some form of distributed tracing and then sort of say, wait, I thought that was supposed to solve everything. And it doesn't. You need to have analytical tools built around that. It's a yes and on needing both of those. It's not one or the other. But I completely agree with you, Ted, that the data source itself is just it's a necessary thing to solve problems in these distributed systems.
Great. Yeah, and as you said, we should switch to Q&A. We've got about 15 minutes for Q&A. So if people would like to ask questions, you can use the Q&A tool. So there's a little tool down in your Zoom bar that says Q&A. You can type a question in there, and we'll just try to go through as many as we can. There's already a couple questions in there already. Let's see if we can move through these ones quickly, because I think we solved some of them. Are you saying using some sort of correlation ID across services is an anti-pattern, since that is a manual propagation of context?
I mean, I'm saying that you shouldn't have to do it yourself. That it's not that it's very, very common, but if that's happening and it's going to a logging system, there's probably a less expensive and more effective way to do the same thing. That's what I'm proposing here.
Yeah.
Although it's a migration, of course. Yeah.
Awesome. So isn't most of the traceability needs driven by evolving distributed federated computing of the edge evolution of services? Basically, are we like the shape of how we're computing driving the need for this?
Yeah, definitely. I mean, no one cared about distributed tracing with that, that adjective thrown in front. No one cared about that until distributed systems were commonplace, and now they are. I mean, of course, some form of tracing, kernel tracing, et cetera, has been around for a while, but this sort of the type of stuff we've been talking about, it really is driven by the fact that the systems themselves are being broken into little bits. And once you do that, you need some solution to understanding the lifetime of individual transactions, hence distributed tracing. Yeah.
Yeah. Okay, next up, we have someone asking for a cost analysis of Datadog versus Lightstep.
It's such a softball. Yeah, you don't want to call sales. I understand. Yeah, I mean, there's a couple ways to think about it. There's just the unit costs themselves, where I mean, I don't know. You can compare for yourself, but the unit costs for trace data at Lightstep are incredibly low because of the architecture that we have. It's not that we're cutting into our margin; it's just a different technology that we've built. So you can do the price comparison if you want. I would argue though that really doing that analysis, it's more than just looking at that. It's probably also like, well, what are the workflows you need? Do you need to use tracing for deployments? Do you need to use it for latency analysis? Do you need to use it to understand changes in other forms of data, including metrics? And how well integrated are those pieces? So I would include that in the analysis as well. But yeah, I don't know. The best way to probably get a sense of it would be to go to the Lightstep sandbox, which does not involve talking to a human being if you don't want to, where you can play through different scenarios and understand, what Lightstep's product does with the trace data, and then you can use that in conjunction with the pricing to make an educated decision.
Yeah, I would agree with all of that. Let me see if I can pull up the sandbox real quick for people. So I'm going to post a link just in the chat for everyone to the Lightstep sandbox if people want to play with that. Because I totally agree. It's sometimes hard to understand. Like, you can understand conceptually about how these tools save you time, but I find the best way to do it is to actually do it with your hands and walk through scenarios. And it can be a little hard to test drive all these different tools without sending them lots of data, because at the end of the day, you need a lot of data for any of these statistical tools to be useful, and you need to have like a problem you're trying to solve. And so the Lightstep sandbox is a way to play around with a demo environment that already has lots of data and some problems built in. So definitely everyone check that out. Okay. Good practices for storing traces to reduce cost.
So to reduce cost in the logging, I mean, we talked a little bit about sampling already. I think that that's a piece of it. There are other things that are more advanced that I won't go into, but I think the simplest thing is just like literally moving to tracing and only using the logging system for, kind of the things that have to be done in the logging system, usually some kind of BI use cases or certain security use cases. But if you're using logging to record every transaction, every service, just simply moving over to a tracing system will save a lot of money right off the bat. And then within that tracing system, you can optimize, with different approaches to sampling on the ROI. I mean, you lose something when you sample too, but you can find the right threshold. And I promise it'll end up with a lower bill than you started with for logging.
Yeah, agree there. Okay, so next up is open tracing, and I would say open tracing, OpenTelemetry, already included in mainstream databases.
Sort of. I mean, some, not all. I would say that many are moving that direction. I know that the Amazon Web Services suite in general, Amazon's done a lot of really great work on OpenTelemetry, and I applaud them for making those contributions. But among other things, they're building in the OpenTelemetry protocol into a lot of even their, proprietary managed services. It's on their roadmap to have visibility into those. So, but there are other things like SAP and Oracle and stuff that, to the best of my knowledge, have not actually adopted OpenTelemetry. Although I think that's conceivable. I just don't know. I don't have access to the roadmaps and things like that. And then there are others like Cockroach, for instance, where they've had it from day one and very progressive, and you can see all the way inside the database. It's actually really amazing. So it just depends. Is the short answer.
And I would add, this is something I would expect to see more of over the timeline of like the next couple of years as it all stabilizes.
Yeah, it's a when, not an if on a lot of it, but I don't know when.
So there's a number of questions here. There's one in the chat. I actually just want to switch over to that one because I think it's an important question for practical needs for systems that have already been built without tracing. What advice, guidance can you share on how best to introduce tracing?
Yeah, it's a really, really good question. Thanks for picking that one out, Ted. The best advice I can give is to not try and introduce it across your entire application all at once, and also not to start in the fringe. The best thing to do is to find the part of your system that actually sees, it's usually something towards the top of the stack that sees customer requests and then routes them to different services. Like start there and pick the most valuable paths for transactions and instrument that first. It might even just be like 3 or 5 services, but if you don't have that yet, adding those 3 or 5 services and to some kind of tracing system will unlock a huge amount of value and get some quick wins. And then I think from there you can basically follow the critical path of your transactions, where they're slow, where there are errors, to integrate incrementally with the tracing system. But even if you only have 50% coverage, you're going to have a huge amount of value, both in terms of insights that you get and potential cost reductions. So that's the advice I'd give.
Yeah. And I might follow up with that by just mentioning OpenTelemetry is the new kind of standard tool for adding tracing to your system. And if you use OpenTelemetry, assuming you're using a system that's built out of open source components or common shared components like HTTP clients and web frameworks and things like that, just adding the context propagation is the most important part. So just adding OpenTelemetry, assuming the instrumentation OpenTelemetry comes with covers the libraries that you're using, that is usually enough to get a service instrumented sufficiently. You don't necessarily need to go in and and add a bunch of instrumentation everywhere into your application. It's better to just make sure you've got that basic instrumentation of your open source libraries and your frameworks, and getting all of the services in that particular transactional chain lined up with that kind of coarse-grained tracing before writing a lot of detail.
Yeah, absolutely. And thanks for bringing up OpenTelemetry. Yeah, that the first thing is OpenTelemetry, and then the other thing I said. Yeah.
Great. Okay, so we got about 5 minutes left. Gonna keep going back to the Q&As. How well do enterprise architects understand these distinctions and need for analytics? How can traceability create better exchange between platform service architects and the DevOps folks?
I can't really speculate about how enterprise architects do or don't understand things like this. I will say that that tracing has absolutely created a ground truth for various debates within software engineering organizations, where you often will see something where there's an outage and two groups are on either side of it, and they'll kind of be pointing fingers at each other to say, oh, they're the ones who are responsible for this, and vice versa. And tracing can answer those questions with data, which I think is really helpful for everybody. So yeah, I mean, it's helpful for communication stuff, but I think there's probably a question behind the question that Michael's asking here that I would need more time and follow up to get to the heart of. But it's certainly helpful, I'll say that.
Yeah, definitely being able to objectively apply attribution to say where the slowness is coming from in a chain of components can help drive some of these conversations. All right, next up from Andre, are there open source tools or open literature describing methods of using traces for anomaly detection? Or does one use the anomaly to trigger digging into traces in the first place?
Definitely a both. And there is some literature about this. I will just say about automated anomaly detection, the issue is always, it's never been automatically finding anomalies. That's actually pretty easy. The hard thing is that you find a lot of false positives. That's typically where the issues are. My opinion anyway, is that something like SLOs SLOs do that's service level objectives, so like goals per service for reliability, basically. Like having those established is extremely helpful in ranking the various signals that you're getting. The issue with anomaly detection is that when there's an issue somewhere, it probably is an issue everywhere, or at least in many places, and so you end up with a lot of redundant anomalies that are really talking about the same thing. Tracing can help with that, but it's not like a panacea, especially if you don't have an objective function like an SLO. Anyway, in terms of actual pointers, maybe we can follow up afterwards and send out some links to suggested articles and things. But there certainly is both academic research and a lot of marketing material about how to do this automatically.
Yeah, but I definitely agree with your statement that it doesn't, in my opinion, fundamentally change what people are currently doing. Like the workflow is you're setting up alerts and SLOs, and these are tools that are speeding up the process. But when you veer away from like these tools doing the objective part into something that's more subjective, like tell me that, find a problem, not find an anomaly, but find a problem, that's when it's hard to like trust the tool, because the tool doesn't know what a problem really is. It just knows objective things like this changed. Yeah. All right. Karan asks,
and which this probably should be our last question too, because I do have to go in a minute.
Yeah. Let's end with this one. I think it's a good one. Will distributed tracing help with security use cases in which digging through raw logs is almost unavoidable?
It will certainly help with some. I mean, security, of course, is a really wide field, and there's everything from like, spear phishing email attacks, where I don't think distributed tracing is going to be helpful, to other things where logging really doesn't do much at all, and tracing could be incredibly helpful if you're trying to understand the level of access that individual users have to things that are way down the stack. Tracing can be quite useful for that. This really comes back to that whole sampling discussion. I think with sufficiently sophisticated sampling, tracing can be a stand-in, if not a better than logging for many of these use cases. But I do think that there's still a case to be made. You'll note that I said, reduce logging volumes by 95% or something, but not by 100%. Like there's still a case to be made for the simplicity of raw logging for certain types of use cases. And one of them in my mind is, just recording every request that comes into an application from the outside once and only once. That's valuable. It's just when you record it in every service that it touches, that's when it gets really expensive, and when you're trying to do the work of tracing with an inferior technology. So I think logging still has a role to play in security for the time being, but we'll eventually see these technologies converge. That what I just described is really just a special sampling policy applied to tracing. I think we'll get there. It's just going to take a couple of years.
Awesome. All right. Well, that's all we have time for. Thank you so much, Ben, for sitting down. If people do want to follow up, what's the best way for them to follow up with you?
You can just DM me on Twitter. I'm EL_BHS. It sounds like there are a lot of questions, so maybe we can do another one of these sometime and leave more time for Q&A. Hope it was useful for everyone.
Yeah. All right. Thank you so much, everyone. See you on the internet. Likewise, you can follow up with me. I'm Ted Suo on Twitter. So DM us both there. All right. Cheerio. See you all on the internet.